Every prompt into ChatGPT triggers a massive industrial process. This chart compares a single AI response to a standard Google search. It takes nearly 10 times the electricity. Projected across millions of users, by 2026, data centers will consume as much electricity as Germany. To sustain this, the industry is building at a scale that dwarfs traditional tech hubs. These sprawling complexes require hundreds of acres of land and a direct, high-capacity link to the nearest high-voltage transmission lines. In major hubs like Northern Virginia, the regional power grid is already struggling to deliver electricity to new projects to keep pace with demand. Software companies are now forced to build their own substations and water treatment plants just to keep their expansion plans on schedule. The desperation for power has reached the nuclear level. Microsoft recently signed a 20-year agreement to restart the dormant reactor at 3 Mile Island, securing a carbon-free 24/7 baseload of electricity that the public grid can no longer guarantee. Progress in artificial intelligence is no longer dictated by software breakthroughs or more efficient code. It is gated by the raw generation of industrial megawatts. Raw electricity from a nuclear plant cannot go straight into a microchip. It arrives at hundreds of thousands of volts, but a server rack needs it at a much lower, more precise intensity. Stepping that power down requires this: an electrical transformer. These are 400-ton monoliths of iron and copper, a technology that hasn't changed much since the 19th century. Data from the National Renewable Energy Laboratory shows wait times for these heavy transformers jumped from a few months to over 3 years. Every major AI cluster on the drawing board is currently stalled by this analog bottleneck. The supply chain cannot simply be scaled up. Manufacturing these machines requires specialized grain-oriented electrical steel and miles of high-purity copper wiring, both of which are facing global shortages. The trillion-dollar race for digital superintelligence is currently being held hostage by a lack of rusted iron and spun copper. Even when the power arrives, many existing facilities are physically incapable of using it. The new arrays of AI chips are so heavy and power-dense that standard data center floors would crack under their weight, and their electrical panels would melt under the load. To solve this, engineers have moved to rack-scale clusters. Instead of individual computers, they pack 72 high-performance processors into a single unified cabinet that functions as one giant machine. Pushing that much processing power into a single cabinet creates a heat density equivalent to over 100 kilowatts of energy. It is an environment so hot that traditional cooling methods fail. For decades, we used industrial fans to move cold air through server rooms, but at these densities, the laws of thermodynamics are clear. Air cannot absorb and transport thermal energy fast enough to prevent the hardware from burning itself out. The industry is shifting to direct-to-chip liquid cooling. This involves pumping cold fluid through copper plates sitting directly on the processors, absorbing heat and carrying it away through a complex network of pipes. This is high-stakes engineering. If the cooling flow fails for even 30 seconds, the extreme heat will physically melt $100 million of hardware into scrap metal. The modern AI factory is a high-pressure plumbing system where thermodynamic survival is the only priority. This isn't just happening in server rooms. If we zoom out, we can see the physical footprint of AI expanding across the landscape. We are watching the growth of a new industrial layer overlaid on the Earth's physical crust, a network of heavy infrastructure that consumes millions of gallons of water and redirects the planet's power grids. This physical reality is creating a new geopolitical tension. Governments are beginning to treat compute sovereignty as a national security issue, balancing the economic benefits of AI against the massive strain on their public utilities. Ireland provides a clear warning. Data centers already consume nearly 20% of the nation's total electricity. To protect the public grid from collapsing, the government was forced to issue moratoriums on new projects around the capital. We often discuss the future of AI in terms of algorithms and code, as if the only limit is the creativity of a software engineer. But the final boundary for this technology is determined by the laws of civil engineering and thermodynamics. We're terraforming the planet's energy infrastructure to meet the demands of a machine